Okay, 7th grade, this is chapter 6, section 2, graphs of linear equations. We are going to spend bonus days on this. We're spending 3 days on this. This is super critical that we can graph a linear equation. A linear equation. When we look at this word, there are 2 small words hidden in it. And so every time we graph a linear equation, no, we are not graphing ears. We are graphing, the word that you can see is lines. Good. So graphs of linear equations have 2 variables. The graph is always a line. This whole chapter is about lines. If you start graphing points and see a triangle come out, probably you made an error. So when you don't see your points lining up in a beautiful straight line, rework your math. Maybe there was a negative issue, or you added a positive and a negative wrong, or it's usually negatives, isn't it, 7th grade, right? Yes. It's a negative year. Okay. Before we write the steps, we are going to try graphing a linear equation. And here you go, the first one. Y equals negative x plus 2. So if we're going to graph an equation, what do we need? It will look like a line. What do we need? I have this equation. It doesn't really tell me which direction to go at this point. So what do you need if you're going to put this on a graph? Jeremy?
Maybe x and y.
Good, we need x and y, because what are x and y? Together?
They're like the terms. They're usually where the point.
Very good. He says it's a point. X, y together is a point, right? So how many points do you honestly need to graph a line? You need to know how many minimum points. Zach? 2 points. 2 points, and then you would just connect them and extend it, right? I'm going to ask you to find more than 2 points, because sometimes we have math errors. And so if we only find 2 points and one was an error, you have now graphed a completely wrong line. You understand? So today we're going to, in this early part of the chapter, use 5 points minimum. When you get to your assignment, use 5 points minimum. Find 5 points, then go graph. If you have made a math error, you'll see it. It will not look like a line. Okay? So let's put this equation in a special table. We're going to input x. We're going to get out ordered pairs. Let's bring the whole ordered pair out. Okay, so we're making a table. Inside the table, we can put this function. Remember that when we isolate y, it was called function form. We can put stuff in and out pops y. Put an x in, out pops a y. That's a function. Okay? We could leave the equation looking as it is, or we could go ahead and move the y to the back. And I like doing that sometimes because we're inputting x's. So if I write the equation with the y at the back side, I can input the x, and then to the right out pops my y, right? So this is one way we could write the equation. So we'll do it this way. So give me a few of the values we've said are great inputs. Give me one. My favorite input is
0.
Good. So let's input 0. I'm going to put that in the middle of the table. Because why do you think I would put that in the middle of the table? Carly? Good. So we could do negatives above it, and then below it we would do positives. So how about 2 negatives and 2 positives? Right? So what is just a little less than 0?
Negative
1. And a little less than that?
Negative 2.
A little greater than 0?
1.
And greater?
2.
2. Good. So now we're going to input these exactly into the function that we have. So we're going to write the function as we see it. I have negative. Okay, there is x. So we're going to substitute negative 2 and finish the function. So what is the negative of negative 2? Negative of negative 2 is 2. This becomes 2. 2 plus 2 is 4. So our first value, when we plug in -2, we get a y value of 4. We'll do the same with all of these. When we plug in -1, you notice that that negative out there changes the x to its opposite, right? So what is the opposite of -1?
1.
Plus 2?
3.
Good. Okay, plugging in 0. This is an easy one to plug in, right? -0 is
0.
plain old 0. 0 plus 2 is
2.
0, 2. Again, we have negative. Now we're plugging in just a x value of 1. So this is even a little trickier than the negatives in a way, isn't it? What is the opposite of 1?
Negative.
And -1 plus 2 is
1.
1. Good. So we have a point 1, 1. And finally, we're plugging in an x value of 2. This is a fun one because when we have -2 plus 2, we end up with
0.
0. Like that one. Okay, so we have a nice set of solutions, and now we can go plot them. Okay, I got rid of the coordinate plane because most people here do not have graph paper in front of you. Even if you do have graph paper, it wasn't with an x and a y axis, right? So if you're just working with notebook paper, or if you have graph paper, at this point we need to draw a coordinate plane. So I have a y-axis. You must label. Notice there are arrows on both ends, right? And I have an x-axis. Don't forget to label it. I'm going to get rid of that 10. As I look at the values in my table, the greatest number in this table is what? Greatest number is 4. So I don't need to go out to 10 even, do I? I'm going to go ahead and use a scale of 1, and each dash I make is going to represent, I'm going to go out 5. Okay? So 1, 2, 3, 4, 5. It's really important that you try to space these evenly, or you will have a graph that looks really awkward and it doesn't show you a perfect line. Graph paper is the preferred choice right now. Okay? So we're going to try to space these the same way as best you can. And you need to label one number in each direction so that anyone reading this knows what you were using as far as your number lines go. Okay? Remember, we have a horizontal number line, the x-axis, and a vertical number line, the y-axis. So once you have it, it may not be totally perfect like graph paper, but it's pretty nice, right? We're ready to find our and locate our points. We can start right at the top of this table. And who remembers the phrase that we can use in locating the point? Do you remember the phrase? Lexi?
Walk before you fly, X before Y.
Good. X, there's more than one way to say it, but you must walk before you fly. X comes before Y, right? So we start at point 0, 0. We always start at the point of origin to locate a point, right? It all originates from 0, 0. And in the first case here, we're going to walk -2 and fly 4. There it is. Second point, we're going to walk -1 and fly 3. And this board is not perfectly calibrated, so do the best you can on your paper. Next point, we're going to walk 0 and fly 2. So does this look like I'm forming a line?
Yeah.
That's good news because this is a chapter on linear equations, lines. That's what we want, is a line. Next point is walk 1, fly 1. Woo. Walk 2, fly 0. And yay, it's all a beautiful line. This is good. What's the final step in graphing these?
Draw.
Got to do one more thing. Okay, Casey, say it loud.
Like draw a line.
Draw
like
the
connect
line.
them.
Connect the dots. Because again, we could have chosen any x values. We could have chosen all numbers in the whole universe, right? And so we can show that by connecting these.
Yeah.
This is not very perfect.
Connect the dots.
Use a ruler.
Connect the dots.
And extending them. Okay? On paper, use a ruler. I'm going to give you a note card like this. to use as a straight edge so you can be as precise as can be on your paper. Okay, keep that in your concept book and you always have a straight edge to use. All right? Questions? Second, let me pause this. Okay, your task is to, oh, we've got to do this, I'm sorry. Let's write the steps to graphing a linear equation. And then your task, of course, will be to graph linear equations. Well, we'll go back. The first thing we do with graphing a linear equation is to put that equation in function form. Isolate y. Once we have y isolated, what did we find? What did we look for? Anybody? What did we need in order to graph a linear equation? Bella?
X are the answers for X and Y.
We call those solutions, or they could also be known as, anybody else? A P word? Say it. Points. Points. Okay, so we make a table, and today I'm asking you to find 5 points. 2 negative, 2 positive, and our nice 0 for x, okay? And then once you have points, we just simply plot them on the graph, right? And draw your line. Make sure your line has arrowheads on either end to represent the fact that solutions are infinite, right? We could keep putting x's in forever, but we don't have to. We know where they would be. Use your arrowheads, okay? Okay, so today, before you move into your assignment, you're going to do here it is, one equation I'm going to have to check. So you are to go get that equation, and I'm going to copy this. You're going to do this equation in your concept book right now. Do this equation on a graph. You're using a table. Graph it. Leave it open on your desk. I will come around and put a star on it, or I'll help you fix it before we put the star on it. You don't need to raise your hand when you're done. Just leave it open on your desk, and you may begin this assignment, which is more graphing. Now, if you need to borrow graph paper because you don't have any, please do. I have graph paper in the black tray and in the shelf underneath those pictures. When you borrow paper, please take 5 or 6 pieces. Store it in your folder, and then the next couple days you have graph paper. You'll be using it throughout the chapter. So stock up a little bit. Take care of it, and then you don't have to jump up every day there's assignment. Okay?